Hello and welcome to today's webinar. My name is Jason Mercer and I will be your host today. Today's webinar is Staying Compliant with Stormwater Discharge Permitting, presented by Dom Goebel. Today, Dom will cover the additional permitting requirements that cities and contractors are facing to responsibly manage stormwater discharge from construction sites. Dominic is a civil engineer with experience in areas of municipal and private engineering design and analysis, including water, wastewater, stormwater discharge permitting, land development, bidding, contract administration, and inspection. He developed and instructs a stormwater pollution prevention plan administrator certification training to certify SWIP administrators throughout the state of Montana. We'll get to Dom's presentation momentarily, but first a couple logistical comments. If anyone has any questions during today's presentation, you can submit them through the questions panel on your webinar interface, and we will answer as many as time allows for after the presentation. Today's webinar will also be recorded and posted to our website later this week, and we will post today's PowerPoint slides if you would like to access those as well. If you are an engineer seeking PDH credits, this session may meet requirements for PDHs depending on your professional registration and/or certification requirements. If you would like a certificate of participation to validate your attendance, please email Jenna Comstock at jcomstock@m-m.net to request one. Okay, without further ado, I'll pass the controls to Dom. And Dom, when you are ready, take it away.
Thanks, Jason. Thanks everyone for being part of this webinar. As discussed, I have developed a class that Morrison-Maierle has partnered with the Montana Contractors Association to certify the SWIP administrators throughout the state of Montana. And to do a certification, we'll be talking about the general permit for stormwater discharge associated with construction activity, which is administered by the state of Montana. It's administered in all areas of the state of Montana except on Indian reservations. EPA has authority on the Indian reservations. So the Montana Pollution Discharge Elimination System permitting program is what is administers this permit. So for this permit, if you have a construction site that is disturbing over an acre of soil and you have stormwater that is discharging from your site, you'll need to obtain this stormwater construction general permit associated with construction activity. So those are the two requirements. That is an and statement, not an or, so you need to meet both of those requirements to obtain this permit. This permit allows you to discharge stormwater from your construction site. Without this permit, you're actually not authorized to discharge any type of stormwater from the site. And with this permitting, there's some requirements on discharging pollutants with that stormwater. So to be compliant with this permit, we're going to have to minimize the amount of pollutants discharged from your site. We're going to reduce those. This requirement, DEQ has a requirement of discharging to surface water. Surface water includes any body of water, irrigation system, or drainage system, either surface or underground. So as part of this permit, I said that it needs to regulate the pollutants discharging from your site. So when you are submitting for this application for this permit, you're gonna have to develop a stormwater pollution prevention plan, or a SWIP. And the SWIP is a document that must be developed and implemented in accordance with good engineering, selection, and design, hydraulic principles, and pollution control practices to minimize control pollutants in stormwater associated with construction activity. So when you're developing this SWIP and submitting it to DEQ, you're going to have to describe construction activities in the project characteristics, describe all potential pollutants that may affect the quality of stormwater. You have to describe best management practices, or BMPs, used to reduce potential pollutants in stormwater. We got to describe the measures to achieve vegetative coverage after soil disturbing activities have completed, and describe inspection and maintenance procedures implemented to maintain all BMPs identified in the SWIP. In this SWIP, you can get from DEQ's, download it from DEQ's website, the 10-page form, fill out, complete it, and then submit it to DEQ. This stormwater pollution prevention plan, it's a living document. It can be revised and updated throughout the entire project. So if you are noticing that you submit the SWIP and then construction starting and you determine that that SWIP is inadequate to prevent pollutants from discharging from the site, you can then revise the SWIP, add additional BMPs to ensure that you're minimizing pollutants from discharging from the site. As part of this SWIP too, you'll have to prepare a SWIP site map. It's a plan map to display site conditions and all BMPs to be implemented on your construction site. A certified SWIP preparer must prepare this application and the SWIP. The SWIP preparer is an individual who is responsible for the planning and development of the SWIP. You must be certified to prepare this SWIP, and so you'll have to take training or certification to be qualified as a SWIP preparer. So the SWIP preparer will submit and prepare the SWIP, and as part of that, they're going to design and describe best management practices to be used to prevent sediment from being, or pollutants from discharging from the site. So best management practices, BMP, is a minimum level of treatment must be achieved through the good engineering selection and design implementation, installation, and maintenance of BMPs for all authorized stormwater discharges. And you can see right there, this is DEQ's definition of a best management practice: the schedule of activities, prohibition of practices, maintenance procedures, and other management practices to prevent or reduce pollutants of state surface water. So I'd like to show this photo here. This is when I've been doing my own inspections for a permit. This is a picture of a subdivision with no BMPs implemented on the construction site. So you can see sediment is on the road, there's materials, there's equipment, vehicles that are parked on the road, really no way of containing that sediment. So if there's any type of stormwater, rain, snow melt, anything like that, on a day could then carry out all the pollutants and then discharge into a water body and reducing the quality, the water quality of that surface water. So when we are developing and preparing our SWIP, we're going to be implementing, installing BMPs and do best management practices to prevent any type of pollutants from being discharged from a construction site. So when we are describing best management practices, there are 3 different BMPs that we're going to be looking at installing. We have erosion control BMPs, soil stabilization to protect the soil surface against erosion mechanisms such as water or wind. Really, when we're looking at erosion control BMPs, we're trying to keep the dirt in place. Underlying layers of soil are more susceptible to erosion, so we can keep that vegetation there, keep the topsoil there, prevent erosion from occurring, keep that dirt in place, keep that pollutant at the source right there, really minimizes the amount of pollutants that can be discharged in that stormwater. There's also sediment control BMPs. These are practices that trap soil particles after they've already been dislodged and minimizes the soil particles to be carried off-site through stormwater discharge. So when we're looking at sediment control, this is really a second line of defense. So the erosion control BMPs are going to be the most effective way of controlling and minimizing pollutants from being discharged from a site, but there is a potential for soil particles to be dislodged and carried in that stormwater. So then we want to look down gradient, have some type of sediment control in place to prevent any sediment that has been dislodged. So don't just design or don't just place sediment control BMPs. really use a combination of BMPs, use the erosion control BMPs at the source and then sediment control downstream, down gradient. There's also good housekeeping, waste management. Construction sites are just gonna have a lot of hazardous materials, waste materials that we're gonna try and prevent from discharging the site. So good housekeeping practices to prevent pollutants from vehicle equipment cleaning and fueling, material stockpiles, paving and grinding operations, and soil, liquid, hazardous, and concrete waste. So we're just gonna go through some examples of BMPs. When you're preparing a SWIP, these are BMPs that you're gonna be calling out potentially to minimize the pollutants from discharge. So the first one is a picture of natural vegetation. It's an erosion control BMP. The purpose of this BMP is to protect existing natural vegetation within the construction site, to minimize the amount of bare soil exposed to erosion, reduce the velocity of stormwater runoff, reduce the erosion and raindrop impact on the soils, allows water to permeate through the soil, provides a buffer and biofiltration, and is aesthetically appealing for a construction site. This BMP is most effective at controlling erosion and sedimentation at the site perimeter, slopes, toe of slopes, near water and wetlands. It's really the most effective BMP that we can use for preventing pollutants from discharging from the site. You know, keeping that pollutants there at the source, most inexpensive. You know, it's free. It's right there already on the site. So if we can use that natural vegetation for our construction sites, really is beneficial to prevent sediment from being discharged from the site. So like I said, that's an erosion control BMP. Example of a sediment control BMP is a silt fence. BMP here is designed to intercept and slow sediment-laden sheet flow. Allows for sediment to settle before the stormwater discharges from the site. So it'll catch any sediment that the stormwater is catching or that's carrying, and then allow for water the sediment to settle before the stormwater discharges. Now this BMP is most effective when installed at the site perimeter, the toe of slopes, near water wetlands, and at the pollutant sources. With this BMP though, it's a common BMP that you see on construction sites. It's just a pain though to maintain. It requires intensive maintenance to remain effective and cannot be used in concentrated flows. So this is a BMP that you see on a lot of sites, but it is, I always call it a maintenance nightmare. It's, you know, there's the wooden stakes that are gonna be breaking. That fabric there is only really designed for 5 to 8 months. Then it's gonna rip, tear. So it's just gonna require a lot of maintenance for it to be effective. Right here we have a rock sock. It's a sediment control BMP. It's designed to slow stormwater flow and trap sediment from discharging from the site. It's most effective when installed at inlet outlets, near water, wetlands, and impervious surfaces. I like this photo. This is a good photo just to show how effective this BMP is at preventing sediment from discharging from a site. You can see on the left right there, all that sediment that's trapping, and on the right there, really is minimal sediment that is discharged from the site. And this is a really good BMP to use when you're using it on asphalt or any other type of impervious surface. It is important though is that to know about this BMP is that ponding can occur. It can get clogged and it won't allow for water to flow through it. And you can even see right there on the left, you can start to see some ponding occurring. So you want to make sure with this BMP that you're maintaining it, removing that sediment, and just inspecting to make sure that it's not clogged and not causing any flooding to occur, especially if it's flooding onto a public road. The next couple of photos I have here are trackout devices. Construction sites, if they're unprotected at the access, sediment can be tracked onto roads, which causes, you know, any neighbors, the public can see it. That stormwater can then, those pollutants can then be carried into any type of inlet protection where it can then discharge into a water body. So we want to make sure that we have some trackout devices at the entrance or exit of a construction site. This is a rumble strip right here. This is a BMP that reduces sediment from being tracked onto public roads. Installed at site entrances. some installation requirements is that it needs to be out a minimum of 12 feet wide by 50 feet long and have a geotextile underneath it. I have a rumble strip right here. It's a really effective BMP at the track out device. You can use large angular aggregate gravel. You can also use cattle guards or FODs. This is a FOD right here. It's a BMP that I've learned from a lot of contractors. It's a really durable BMP. It can be used on multiple projects. It's not the most it's not the cheapest BMP, but since it can be used on multiple projects, it can really be cost savings in the long run. It's a really effective way of preventing sediment from being tracked onto roads. So recommend the FODs be used as a track-out device as well. This BMP right here is a straw wattle. It's also used as a sediment control. This is a BMP. It's designed to intercept stormwater runoff, reduce stormwater flow velocities, capture sediment, and promote infiltration. It's most effective when installed at the site perimeter and at exposed areas, slopes, toe slopes, near water, wetlands, pollution sources. I see this when I'm doing my inspections for this permit, that it's not trenched. You want to make sure that this BMP is trenched in disturbed soils. If it's not trenched, stormwater can undermine it and allowing for stormwater and access to discharge from your site. Also important to know is that this BMP does not allow water to flow through it. It creates ponding as well. So when we're looking at using it around an inlet, if someone wants to use around an inlet, it actually won't allow for water to flow through it. And like I said, that's where ponding and flooding can occur. Which then brings us to inlet protection. Here are just 4 different examples of inlet protection. Sediment control right here. These BMPs are designed to capture sediment before the stormwater discharges into the inlet. That inlet has a direct route to our state waters. There's a lot of options to use for inlet protection. On the upper left right there, the green, that is a compost filter sock. On the right, there's a Durawaddle. On the left, right there, bottom left, that is a dandy bag. And on the bottom right, it's a witch's hat. I kind of like all of these. I've not used a lot of filter socks before. I've learned from contractors, like say in Bozeman, they are always talking about this filter socks. The BMPs on the lower left, the dandy bag, contractors in Billings, they are loving this BMP. The BMP on the right there, that's a photo that I took in Missoula, and that's a BMP that's actually designed to be driven over. It can drive over it. And then there's the witch's hat, which can fit inside that inlet right there. With anything just like that rock stock, whatever you use, you want to make sure that you're doing the inspections for this, making sure that there's no ponding or clogging that's resulting in flooding back into the public roads. When we look at these inlets are designed to capture stormwater. So if you're not letting them be used for its intended use, you're going to create some ponding, or if stormwater is just going to go right around that inlet and go to the next inlet, it could get overwhelmed because it's not designed to handle that much volume of stormwater. So making sure that whatever you use for inlet protection, you're doing routine inspections to make sure no clogging, flooding occurs. Right here we have erosion control blankets. It is an erosion control BMP designed to temporarily stabilize soils, protects disturbed soils from erosion, reduces rainfall impact, improves infiltration, and it promotes vegetative growth. So if we're using this BMP, there are some alternatives to it. There's hydraulic or straw mulch or temporary seeding. Whatever you use for that erosion control for slopes, disturbed slopes, whether it's hydraulic or straw mulch or these erosion control blankets, you want to make sure that you're roughening this disturbed soil, placing seeding after you roughen it, and then prior to the installation of the erosion control. So this is on any disturbed soils that you're trying to get some vegetative growth, that final stabilization. This is a good BMP to use. You can start to get some vegetation to grow, which then creates some roots to be established, which then binds that disturbed soil. With these BMPs, though, they're usually labor intensive, which could affect your decision to choose this. This BMP right here, this is these are concrete washouts. For this contractor right here, they use kiddie pools to use as a way to contain concrete waste material. Really, when we're using these concrete washouts for construction site, truck driver, after they are pouring the concrete, they need to wash out the chutes. That's really what we're trying to contain right there, is that wash water from the truck right there. That wash water contains contaminants from the concrete that can then enter our aquifer and pollute our state waters that way. There's multiple options to use. Like I said, this one's just a kiddie pool. You can dig a hole, line it. You have above ground construction concrete washouts where you're making sure you're lined it. There's a lot of commercial products that you can use. So just making sure you have a way of using a concrete washout, make it easily accessible for the concrete truck drivers. Place them where concrete's being poured. Just makes it more likely to be used. I know that I'm an engineer, I've been on construction sites, I'm a SWIP administrator. I've seen how it is with a lot of these, is that they wash out right where they're pouring the concrete. So if there's no way of containing that, that wash water can then enter the aquifer. And then with this BMP, you want to make sure that you are disposing the concrete once it cures. So the SWIP preparer is preparing, they're identifying, designing BMPs for your construction site, calling them out. Then once DEQ authorizes you to discharge stormwater from your site through a confirmation letter, then SWIP administrator takes over and then does performs inspection. So a SWIP administrator is someone who is responsible for developing, implementing, maintaining, revising, and updates the SWIP. Someone who must be knowledgeable of the principles and practices of erosion and sediment controls. They must possess the skills necessary to perform inspections to assess site conditions and determine the effectiveness of selected BMPs. This is someone also who is an authorized representative of the owner and can sign documents and other information requested by DEQ. Just as the SWIP preparer, the SWIP administrator must obtain valid certification. And this is what Morrison-Maierle has teamed up with the Montana Contractors Association to put on the class. So this is the class that I teach throughout the state of Montana, is certification for SWIP administrators. It's important to know that a SWIP administrator can prepare a SWIP. SWIP preparers cannot administer the SWIP. So that's important to know, is that the SWIP administrator meets both qualifications as the administrator and the preparer. So you can just have one person be the preparer and the administrator, but they must be a certified SWIP administrator to do that. So as part of a SWIP administrator, they're going to be performing inspections, making sure that BMPs are effective and in effective operating conditions, trying to minimize pollutants from discharging from the site. So when a SWIP administrator is performing their inspections, they're going to be making sure that BMPs are in effective operating conditions, and BMP design standards will identify if BMPs are in effective operating conditions. There's a few different design standards that you can use. I have some examples here of the MDT Erosion Sediment Control Best Management Practice Manual. MDEQ has a field guide for best management practices. There's another one out of Denver, the Urban Storage Drainage Criteria Manual, that identify BMPs. And also municipalities throughout the state of Montana also have design standards that they'd like you for you to install BMPs. But the design standards must include design, installation, implementation, and maintenance procedures. There's many options, like I said. I personally like to use the MDT manual. The reason I use it is that it has pictures of the BMPs, has definitions and purposes of the BMPs, the objective, the effectiveness of the BMP, any alternatives of the BMP that you're trying to choose. BMPs you can use in conjunction with, the limitations, materials, design, installation. the inspection and maintenance procedures for the BMP, removal, and also has details for the BMP. These BMPs must be kept on site. And like I said, this is a way to make sure when you're performing your inspections, the administrator has to perform inspections to be compliant with DEQ on a weekly or bi-weekly frequency. So when they're going on inspection, they're going to be using these BMP standards to make sure that those BMPs that were installed originally are still in effective operating condition to prevent sediment from discharging from the site. So I have some photos here that I'm going to show you of BMPs that are no longer in effective operating condition. They're not preventing sediment from being discharged from the site. So the first one right here is a silt fence. The BMP standards for this, when you reach the end of one silt fence and start another silt fence, is that you wrap the joints around each other, wrapping them around them, so then there's no gap in between the two different silt fence. So you can see right here, they weren't wrapped, they're just overlap, just passing. So now there's a gap in between the two fences, which then is allowing sediment to go right around them and then discharging from the construction site. So when you're a SWIP administrator, you have to identify if BMPs are no longer in effective operating condition. If they're not, then you have to determine corrective action that needs to take place so those BMPs are in effective operating condition. So this is an example of a corrective action, is making sure that you're wrapping those posts around each other and making sure you're removing the sediment that's discharged from the site. Right here, this photo is oil from a skid steer. Whoever the contractor was on this, that fuel started to leak, and you can see it's being carried in the flow line of that curb, which is then most likely discharging from the site through the inlet. This is actually a prohibited discharge from, you're not allowed to discharge this pollutant at all. And so what the contractor used here was a straw wattle. Well, this BMP, the straw wattle, is not adequate for the pollutant, or it's not even installed correctly either. Straw wattle needs to be staked in the ground and needs to be trenched in. So you can see right here, it's not staked, it's not trenched in, and it's just allowing for oil to flow right underneath it, and it's not preventing that oil from discharging from the site. So corrective actions here is place an absorbent on the surface and place a container under the leak to contain the oil. This photo right here shows the disturbed slope that has no BMPs installed on the slope. You can start to see that erosion that's occurred, which has then removed a large volume of sediment from this photo. And actually, you can't see this, but it's actually discharging down. All the sediment crossed over the dirt road right there, went down another slope, and there's actually such a large volume of sediment that overtopped down gradient silt fence. So the contractor here was only relying on a silt fence, a second sediment control BMP, and they didn't have any erosion control BMP, and it resulted in that down gradient silt fence being overwhelmed and not preventing sediment from being discharged. So with this photo right here, some corrective actions that could take place is roughen the surface and then install erosion control on the disturbed soil, whether that's temporary seeding, erosion control blankets, or hydraulic mulch, whatever it may be. Erosion control BMPs need to be installed on this slope to prevent sediment from being carried and overwhelming that silt fence. This photo right here shows a straw wattle that's used to protect inlet. This BMP is not installed correctly and it's not adequate for the pollutant source. Again, like the previous skid steer, the straw wattle is not staked or it's not trenched, which is resulting in sediment discharging into that inlet. So corrective actions is to replace the straw wattle with a different BMP, whether that's a witch's hat, Dura-Wattle, rock sock, compost filter socks, or other BMPs similar to that would be able to place on top of an impervious surface or within, or be fit, or it can fit in the inlet. And that's the video right here. This is a photo. I think is a really good photo. It's not good in the result in the sense that sediment's being discharged into a creek, but really is showing how this straw wall that is staked and it trenched is still being overwhelmed, resulting in sediment being carried directly into our water bodies, polluting the water quality standard of this creek. So corrective actions for this is that this BMP, while it's installed correctly, is not effective at preventing sediment from discharging into the water body. You see the sediments overtopping the straw wattle. So a couple different ideas for corrective actions: replace the straw wattle with a different BMP, maybe a silt fence, earth berm, something a little bit taller, so the sediment doesn't overtop the straw wattle. Or you can also install some BMPs up gradient to control that stormwater volume and to control the sediment. So then that straw wattle is not being overwhelmed by the volume of the stormwater and as well as that sediment. And something that's interesting about this, this was a project that I was a SWIP administrator for. So I had to submit a non-compliance report to DEQ since sediment was being discharged into the water body here. So as part of this permit, to be compliant, you'll have to submit non-compliance reports to DEQ if you're not compliant with the general permit. I also want to make aware of something that came just effective this year, January 1st of 2021, is that public signs need to be installed on construction sites. Needs to be large, readable font, and must be placed in close proximity to construction activities and visible from the nearest road. It must have the Montana Pollution Discharge Elimination System authorization number or confirmation letter for the permit that you've received from DEQ. And this language needs to be included on it. Request project information from Montana DEQ Water Protection Bureau at 406-444-3080, and it must be placed in a safe and accessible location. So anyone near the site, the public can then see this, and if you are tracking sediment onto, say, a road, could result in someone calling on a construction project, which then could result in inspection from DEQ or a municipality. So as part of this permit is that you submit it to DEQ, you received authorization from DEQ to discharge stormwater from the site, and then after you have reached final stabilization, you can then terminate the coverage of the permit. So you must submit a notice of termination or the NOT to DEQ. You are eligible to terminate your coverage once you've reached final stabilization, which is vegetation has reached 70% density of the existing density prior to construction. Also, you have to make sure that completion of pollution-generated activities have completed, removal of equipment and vehicles, and removal of temporary BMPs. It is important to know that this NOT needs to be submitted prior to the first of the year if you have reached the requirements to terminate your coverage. DEQ, as part of this permit, there's a annual fee associated with it. If you have an active permit at the start of the year, you'll have to pay that annual fee. So making sure that if you meet the requirements of this terminating your coverage, that you're submitting it as soon as possible, so you're not seeing that annual fee associated with the permit. So I want to conclude this webinar with the photo that was at the beginning. You can see right here again that this BMP is a culvert with outlet, but there is no riprap, there's no outlet protection. So it's resulting in erosion occurring, which is resulting in sediment being carried through stormwater, which is then overtopping that silt fence, which is then discharged into surface water. So making sure you're not just relying on sediment control as a protection, but you're having BMP, erosion control BMPs at the source, controlling that stormwater, minimizing velocity, and keeping the dirt in place. So with that, that concludes the webinar. I am open to any questions anyone may have.
Yeah, thanks, Dom. Yeah, we've gotten a few questions in. Just a reminder for those on the webinar that you can submit any additional questions through the question panel there on the screen for you, and we'll take those and ask Don as we have time. So maybe the first question would be is how long does the process take to obtain the certification for an administrator? What does that process look like?
Yeah, no, that's should go into that. So DEQ has some requirements for the providers who are certifying SWIP administrators. It's a minimum of 12 hours. So, you know, our class with Montana Contractors Association, it's a 12-hour certification. Thursday, it's an 8-hour, and then a Friday, it's a 4-hour where a test is administered, and you must pass the test to gain that certification. And then that certification lasts for 3 years. So you'll have to make sure that you'll take a recertification class prior to your certification expiring. And so that recertification is a 6-hour class. And it's just a really refresher, understand what's new with the general permit, a refresher with BMP implementation and design standards.
Okay. And then that recertification, does that apply for another 3 years then?
Yep, exactly, yeah. And then you have, it lasts for 3 years, and then you have to take that recertification. You have 6 months after your certification expires. So if you go past that 6 months after your expiration date, you'll then have to retake that certification class again.
Okay, good. Another question that came up was, what are the requirements for how long BMPs have to be in place after construction?
So with that, it has to really have to do with you know, your permit that terminating your coverage. If it's a temporary BMP, you're gonna want to make sure that you're removing it after construction is completed. But the important thing is you want to make sure that that vegetation has started to grow, like the grass, controlling that sediment on site. There's no necessarily time frame that you have to remove the BMPs, but you want to make sure that that vegetation has taken place before removing the BMPs. You know, if you remove it before that vegetation has taken place, there's potential for stormwater or for sediment to discharge from your site. So that permit has to be active until the vegetation starts to grow.
And then is there a final inspection that's done by DEQ, or is that done by the SWIP administrator and kind of certification that way? What's that process?
Yeah, so there is no, as far as I do believe that different municipalities, they may, if you're working, like say in the city of Missoula or city of Bozeman, they may have their own requirements that require a walkthrough. But as far as this permit associated with DEQ, they don't have a final walkthrough. They don't come by once they receive it. I did find out from a DEQ compliance inspector that they do drive-by inspections for a quarter of the NOTs that they receive. So you know, to determine where your construction site is, they may drive by your site to see if you have reached that final stabilization, that you make sure that you have received, that the grass is starting to grow on your construction site.
Okay. Another question came in, you know, what is considered a pollutant related to SWIP?
Yeah, so this is, DEQ has in their permit, they actually have a definition of what a pollutant is. So let's see. Here it is. So DEQ identifies a pollutant as any dredge spoil, solid waste, incinerator residue, sewage, garbage, sewage sludge, munitions, chemical waste, biological materials, radioactive materials, heat, wrecked or discarded equipment, rock, sand, cellar dirt, and industrial, municipal, and agricultural waste that's discharged into water. So that's what we're trying to minimize. That's what we're trying to prevent from discharging from your point source, your construction site.
Sounds like just about everything.
Exactly, yeah, everything, yeah. Anything that really can degrade the quality of water, our water quality standards.
So Dom, there's a number of folks that are listening in from Wyoming, and do you know, are there similar standards for Wyoming DEQ? Are you aware of kind of what their requirements are, or where they might be able to look for that information?
I'm not as familiar. So I've had people in my class, come from North Dakota, Wyoming. I don't believe that the state of Wyoming has the requirements of a certified SWIP administrator. You want to meet the certification, but it's still the same kind of requirements that the SWIP administrator must have knowledge of Bmps, have access to the site, understand the construction. It's going to be similar. We're really trying to, they're just like state of Montana, Wyoming is going to really have this permit it's to discharge stormwater. So they're going to want to make sure that you're minimizing pollutants from discharging from your site. So they're going to have similar compliance requirements as far as that. They may have differences, like how often you have to do the inspection. Their permitting process may be slightly different, but for the most part, it's going to be similar to what the state of Montana's general permit is. And one way is, to go on to the state of Wyoming DEQ and look at what their general permit has to say. Like I said, from the people who have come to my class that are from Wyoming, it's a very similar requirements for the general permit as the state of Montana.
And so does the SWIP requirements follow the federal EPA requirements?
So EPA, and that's the big thing, right? That there's the EPA, there's a Clean Water Act. State of Montana want to make sure that they don't get any fines resulted from this. So that's why, the states all have their own general permits to make sure that, contractors aren't discharging sediment into water bodies, because the state of Montana violates the EPA Clean Water Act, fines can result from that. So they're going to make sure that they're stringent as the the national pollution discharge elimination system, just because they're going to want to make sure that they're not seeing any fines resulted from sediments being discharged. They're going to meet the requirements. If you do have a project that is, say, on the Indian reservation or something similar, you have to go through EPA's application process. You have to get the EPA stormwater discharge permit. So you have to go through their requirements, and it is different than the state of Montana's, what their requirements are as far as what the submittal, what the form looks like. There's no application fees with the EPAs. I don't believe that they have a template SWIP like the state of Montana does. So you have to create your own at that point. But yeah, the state of Montana will have to make sure that they're compliant with the federal permit as well.
Maybe a follow-up to that question is you mentioned the new public sign requirement. Is that something specific to the state of Montana, or is that an EPA requirement?
I don't know about EPA. I don't believe it's on the EPA general permit. I haven't looked at the EPA. The only thing I know is that, not all the states around Montana have that requirement. So I'm assuming it's not necessarily an EPA. I think it's more state specific. I'm not positive on that one though, but like I said, I just know that other states around Montana don't have that same requirement in their general permit, which makes me lead to think that it's a state specific requirement for that.
Okay. In one of the slides you showed, you said there was I think you had you had to submit a non-compliance report to DEQ. Did you receive a violation from that submittal?
No, not necessarily. I think DEQ is looking at it. It's you submit the non-compliance. It's a record. It keeps them. They keep it on record for that specific permit for your construction site. But they're understanding too that what you're being compliant with DEQ by submitting that non-compliance. So it doesn't necessarily result in a violation from DEQ. Part of that compliance letter you have to submit is how you're going to prevent that non-compliance. So say, like in the photo that you're seeing right now where that sediment's being overtopped that silt fence, this would result in a non-compliance. It needs to be submitted to DEQ. So then as part of that non-compliance report, you have to identify how you're going to ensure that this non-compliance doesn't happen again. So you'll have DEQ doesn't necessarily come out on a compliance inspection as a result of non-compliance. So I always recommend to SWIP administrator, contractors, submit non-compliance. You're working with DEQ at that point. If you're trying to hide something, that's really where violations could result from that. So I'm always pro working with DEQ, let them know what's going on, and submitting non-compliance, because like I said, it doesn't necessarily result in fines or a violation from DEQ coming on to an inspection site.
Yeah, good advice.
Mm-hmm.
Looking through, I think we've kind of, maybe one more question here. Question that came in that said, I didn't catch the name of the sediment control method. You called something like FOD?
Oh, a FOD, yeah. Yeah, so it's FODS. It's a commercial product. Like I said, this is something it's kind of fun doing this SWIP class because I get to go around the state and different cities in Montana, different contractors use different BMPs, and this is a BMP that is, I can get to it really quick. Right here, the FOD right here, it's a track out device. So this is something I learned probably about a year and a half ago, maybe a year ago, that contractors are using around here. It's a plastic, it's a really hard plastic. Those ridges right there, those pyramids right there, create depressions in the tire, and it removes a lot of sediment. Like I said, it's a FOD, it's an FODS, and it's a commercial product that you can purchase.
And you mentioned, Dom, that trucks can drive over that, and it's
Yes.
rated equipment and
yeah, they pride themselves on the vehicles, how heavy they can drive over it. So it's a really durable product, and like I said, contractors say they use it on multiple projects too. So it's a long-lasting BMP. It's like I said, it's a little upfront, it's a little expensive, but where you save money is where you get to use it on multiple projects.
Yeah, another question is, at the end of the project, do you have to submit your inspection forms to DEQ?
No, you keep that. So this is for the state. I know for like the cities, some of them do want to see the inspection reports, but as far as this permit with the state, no, you don't need to submit it, but you do need to have them on file and retain them for at least 3 years. All you're submitting to DEQ is that notice of termination. You retain all the other documents, inspections, all your revisions to the SWIP. You keep those yourself. You don't need to submit them to DEQ.
Okay, great. Well, thanks, Dom. Good presentation. Thanks for answering those questions, and thanks to the participants for submitting those to us. We're going to go ahead and wrap this up. So just a reminder, we'll post today's PowerPoint slides and a recording of today's presentation on our website, m-m.net. And if you're looking for PDH credits, remember to submit those to jcomstock@m-m.net to request one of those, and Jenna will get back to you with that information. Make sure to join us on Wednesday, January 20th for our next webinar on cost-effective repairs with trenchless sewer linings. Registration can be done through our website, again, m-m.net. And finally, we would love to hear from you. Please stay in touch with us on social media through Facebook, Twitter, Instagram, and LinkedIn. Thanks again for joining us today. We hope you can join us next time. Until then, be well and be safe. Goodbye.